humans are successful, a bit too successful. We're taking over too much land and too many bioservices. At the same time, we are wiping out other species of animals. We're extremely messy and wasteful. A byproduct of human activity is pollution and uncontrolled destruction. We are collectively laying waste to our beautiful planet. You can see the side effects of human success everywhere. The destruction of natural environments, polluted rivers, ocean plastics, smog, dying coral reefs, forest destruction, as well as almost daily animal species extinctions. Given the level of CO2 now in the atmosphere, we are looking at living in a 4-degree warmer world by mid to late century. Without altering our basic economic models to better value and protect the natural environment, we will destroy much of what makes this planet so beautiful. Forests, coastlines, wildlife, glacier-capped mountain ranges, coral reefs, beaches, all these will be damaged beyond repair. In a 4-degree warmer world, sea level rise will mean all beaches will be submerged. Coastal cities will be uninhabitable. Trillions of dollars of property will become worthless. Billions of lives will be put in peril. Not in 100 years' time, but within our lifetimes. Earth2Org is a non-profit environmental organization based in Hong Kong. We aim to demonstrate what is happening to our planet with insightful articles and campaigns enhanced by data visualizations to make the consequences of human actions and policies starkly obvious. We use machine learning, computer vision, and data science to create our arguments. We use online publishing, social media, events to communicate to a wide audience. Our aim is to influence opinion and encourage the adoption of logical economic policies that are environmentally sound, which at the same time better protect the long-term welfare of human society. Policies that ensure the Earth can be managed by humans in a way that ensures long-term survival of the vast majority of animal and plant species without damaging degradation of our planet. By showing what happened in the past, what's happening now, and what is most likely to happen in the future, we can shine a light on just how illogical current policy making is. We believe our current pathway can be dramatically altered. Human ingenuity, resourcefulness, and effort can yet avoid the climate change-induced Armageddon. It's time to get involved.
And now I'll give the word to Owen and Alex, our data scientists for today. If the people in the back have a hard time seeing the screen, there are 4 chairs.
But if you cannot see or hear, you can try to come a bit closer. So I'm Alex, Owen. Welcome. So let's a little bit first about what we want to do today. So data science is a huge field, so we cannot cover all of data science in this 90 minutes. I want to give you a very brief introduction of what data science is, things that we can do with it, and if we have time at the end and you're still not too tired, we may have a mini demo, but nothing very complicated, just a little bit of, because there is a lot of misconceptions about what is data science. We want to take a look at what is behind it. A lot of people don't understand what is actually behind data science, and we want to actually clarify those, mystify that a little bit. So we're going to talk about the tools some of the tools that we have, the process that we go through as data scientists, and if we have time, as I say, a small demonstration. A little bit about me. My background is in forestry, but I did my PhD in applied computer science and statistics, which is basically data science. So back then, 20 years ago, the term data science didn't exist, but the field of data science is way older than that. So I did all of that at a time where I have this huge computer, 300 gigabytes, that was like the biggest you could get. It was, and I needed to run something, sometimes the entire weekend to get a tiny result. Now I can do it in 2 seconds on my phone. It's actually, technology has advanced a lot, and that's what a little bit has contributed to data science. The technology that we have nowadays is just what allows us to use data in ways that we weren't able before. Owen?
Yeah. Hi, so my name is Owen. I was actually a biologist until quite recently, and so now I'm the head of the data visualization team or data science team at Earth.org. And what we're trying to do is more data journalism than actual pure data science, because we're trying to tell stories with the data. So we'll get to that part soon, but a little bit about Earth.org first. We're a global nonprofit environmental organization. We're based here, even though there's some other locations, hive locations that we can use. And our goal is to raise awareness about biodiversity loss, as you saw in the video. And we believe that with data, you can create arguments that are difficult to argue against, really. And so the point is to show how illogical current policy making is through facts and data. So we're using data science, visualization, and data journalism, as I said, and we want to inform and educate people, raise awareness, and also elicit reactions in people so that they want to make a change.
Okay, so you know about us, a little bit about you guys. Like from this episode, most of you are students. So just to have an idea of why you are here and what do you want to do with data science.
Hello, my name is Rodrigo, and I just finished my major in data analytics.
Okay.
So why am I interested about this? Well, I'm very interested about it, but I don't know how to answer this question. Like that easily. Fun fact about me, I really like football, like playing football.
So one at the back. Thank you very much. Too shy?
Is anybody here who doesn't know anything about data science?
Yeah, who has some background in data
You all have
science or
some
data
background.
analytics or anything with data? No
Okay,
one.
so you're all data scientists?
So, who has no experience with data or data science? I mean, you're here because you want to know about it, I guess. Someone has data analytics, who knows about data analytics? Nothing? Math? No one? Computer science?
We all
Someone who is computer science? Good, let's take a look at all the different things that we need. It's not about scaling you up, but a little bit of like, if you're interested in data science, so you know what expects you a little bit. So, what is data science? What do you think is data science?
I think it's using data to make more concrete decisions.
Okay, using data to make decision, to improve the decision-making process. Yes, quite common goal in data science.
Something to do with big data.
Something to do with big data. Yeah. Okay. The term big data is very often just thrown around, and a lot of people don't know what big data means. But
Just finding patterns in data.
just finding patterns in data. So like a lot of the stuff that we actually understand about under data science could be say, okay, that's what statistics do. Right? So statistics does a lot of the stuff that people think that data science does a lot more than that. So with statistics, you can find patterns in data, you can analyze data, you can visualize it. So what we want to, you can think of data science as statistics on steroids with a little bit of extra added, there's a little bit. So something that's actually quite important if you look at the name data science. So data science, first of all, is just a set of tools that we use in order to extract useful information out of data. Big data doesn't have to be big data. Nowadays we use big data, but not every data science application uses big data. So the idea is, how do we extract useful information out of data? How do we learn about what this data has to say? But something that's actually quite important in data science, it has any science in it, is that we're actually applying the scientific method to solve a problem. It's actually a problem-solving approach. We want to solve a problem using data. A lot of people have this misconception, oh, data science is, oh, we have data, just look at data and see what comes out of it. And it's actually the opposite. We have a problem, and we define the problem, we say, okay, what data do we need in order to solve this problem? And we create computer experiments, data experiments, We really create a hypothesis, we create an experiment, we test that hypothesis with the experiment, we see if we're actually successful, if not, we go back to the drawing board. It's actually, we apply the scientific processes, scientific method in order to solve problems using data. So that's the science behind data science. It's not just hacking machine models. So there are, if you Google the data scientist Venn diagram, you will find something similar to this. The idea is we need a lot of different skills in order to be successful as data scientists. The first one is programming skills. You can be a data scientist without knowing any programming, because nowadays you can have a lot of tools that are just point and click. You can use Tableau, you can do a lot of stuff with just point and click. You can do a lot of stuff with Excel. You don't really need to program if you want to do some data science. You could do some data science using Excel. You don't have to be a programmer. However, the most powerful tools that we have nowadays are based on programming, especially with Python, R, other programming languages. So knowing some programming will help you out. You don't have to be a computer scientist. So you need to know a little bit basic of how to do stuff. I know a lot of data scientists that just barely know how to write a program so that they can code. You look at the programs and they're horribly written in terms of, from a computer science point of view, but that doesn't matter. As long as you get your problem solved, it can be more efficient. So the better you know how to program, the easier it will become for you. But you don't have to be an expert in programming. So just being a basic programmer is going to be quite useful. The second skill, and that scares a lot of people off, is to have math and statistics knowledge. Now, you don't have to be a genius in math and statistics, but you need to have a grasp of the concepts behind it. Even if you go to free courses online like Coursera or something like that, there will be a lot of math that is thrown around, and if you don't understand what it actually means, it may be actually very lost. So you need to have the ability, even if you don't know the material, to say, okay, I look it up, and I try to understand what is happening. So you don't have to be a mathematician, but you need to be able to understand the concepts behind it. It doesn't mean that you have to be able to, I need to apply all this calculus and all this stuff. That's way too much. But you need to be able to grasp what the connections are in terms of when you're connecting your math and your computer science, your programming, so that you know what is happening. Now, a lot of the tools that we have now for data science, they're basically black boxes. You get something and you say, okay, I put a lot of data inside, I just play around with some parameters, and outside comes something. But if you don't understand a little bit of the programming and the math behind it, then you are not able to actually say if that what came out is good or bad. So because everything is happening within this black box, you don't see actually the calculations and everything happening. It's sometimes difficult to have the intuition to see if what came out of your program makes sense. And just having a general intuition, general understanding about what how math works and everything is actually quite useful. Again, I've seen some people who came in my classes and after 2 lessons they say, I'm going to drop off because it's too much math. No, it's not too much math. It's just the concepts. You need to know, to be a little bit like familiar with matrices and a little bit tiny with calculus, but really basic. Nothing really difficult. Most of the hard stuff has been done for you. And when you have the tools, the hard stuff has been done for you, but you need to understand what is happening in the background. If you really want to specialize in data science and go on to do your own algorithms, things like that, okay, yes, you should be a good mathematician, because then you're going to go into the gritty details and say, okay, I want to create a new algorithm. And yes, you need to know that. But if you want to just learn how to use the tools and use them effectively, just having a conceptual understanding is going to be more than enough. Now, data science doesn't exist in a void. You can have very good programmers and mathematicians. They can do nothing with data science because you need to know about the area that you're working with. In my background, back in the day, I was working with the International Panel of Climate Change. We were doing a lot of basically data science projects based on climate change. And just because my specialization was in forestry and forest ecology, I had big domain knowledge. Sometimes I get clients who say, okay, I want to have this in fintech. And I said, okay, yes, as long as it doesn't get really complicated with some financial stuff, I can help. Once it gets really weird, it's not my field because I'm not really an expert in finance. So sometimes I say, okay, I can create a model, but I don't know if the predictions I'm making financially make sense. So for that, then I will need to work with someone who can understand the area that is being applied to so that it makes sense. So you always need to apply your data science to something in the real world. If not, you're just a programmer. Okay? So you need to have to be grounded somewhere to say, okay, I have this knowledge from this area, and I'm solving this problem in this area, and I understand what is happening. So that's why you will find a lot of people who specialize in data science, and they only specialize in a certain area. There are people who specialize in medical data, for example, people who specialize in financial data and so on. It's impossible to find a data scientist who does everything, just because no one knows everything. So the domain knowledge is actually very important. And again, if you Google the Venn diagram for data scientists, very often you find this domain, this diagram is only these three areas, so everything interlocks. However, there is a fourth thing that's actually very, very important, which is communication. I mentioned 30 years ago, I was working with the climate change panel, and we published these huge books, 2,000 pages, and every single, climate change is happening. That was 20 years ago. And we published all these tables and graphs and everything. But it was so complicated, it was so mathematical and so scientific that most people look at that and say, I don't know, I don't care, I don't understand that. So we actually had so much knowledge, and we had a very important message about climate change, but we actually absolutely and completely failed to communicate that properly to the public. Like 20 years ago, like now you have to climate change denial. But 20 years ago, there were a lot of people who said, climate what? So it was actually even harder. And we totally failed because we had a lot of experts at our fields, but we didn't have someone who was able to take those results, that message, and put that in a way that convinces the public. And that's nowadays one of the most important skills that you will need as a data scientist, because you want to tell a story with your data, present data. That's why now, like in the last 5 years, infographics have exploded. Like if you look into in your Facebook, in my Facebook, there is at least not a day that I don't see someone sharing some infographics somewhere. It has gone down. Like if I look like 1 year back, it was like infographics left, right, and center, like because infographic became like this really important. Oh, let's visualize data, let's present things nicely, and that's still a very, very important tool for a data scientist. And if you look for jobs for data scientists, a lot of them require you to know a little bit of web design, so you can present things graphically, and you need to have a little bit of like graphic design attitude. You don't have to be an expert, but you need to know how to present something visually appealing and things like that. So it has become a very, very important tool as a data scientist, presenting yourself. And of course, there is no one who is equally good in all these areas. That's why, as data scientists, we often work in teams, because someone will be very good at this, someone will be good at this, and someone will be good at this. We actually work together so that we can address all the areas equally well, working as a team. There is still some people who work alone as data scientists, but it's very often for a different group. You won't find someone who says, oh, I can do everything. And if you find someone who says, yeah, I do everything for you, don't hire that person, because it's most likely not true. Or you get everything done, but nothing done at 100%. So be careful with that. And also with your own ambitions. Like identify for yourself which of these areas you really want to push for. You say, okay, I'm a very good programmer, so I want to do a lot of things, or I'm a very good communicator, but I want to learn how I can produce nice infographics and things like that. And then you can focus on that. Don't try to be an expert on all 4 areas. So data science can do a lot of things. Sometimes data science can be quite boring. Like, okay, we're going to do data science. Sometimes it's just about collecting data. A lot of data science projects are just about collecting data, because collecting data is not trivial, it's not easy. It can be something that's actually very, very expensive. There are a lot of companies, high-end consulting companies that really charge an arm and a leg to collect data or give you data because they're collecting data somewhere. So data is a new currency actually. It's actually very expensive, it's very powerful, and just defining good algorithms to collect good data can be just your job as a data scientist to say, okay, I want to identify data sources and I want to collect the data and identify the data and clean that data. That can be already a field of its own when you're just collecting data. Manipulating, sanitizing, and bringing data, so you can have a lot of raw data, and sometimes the raw data is not enough. You need to change the data. You need to get aggregates, things like that. That falls also into data science, data visualizations that we mentioned before. You mentioned about understanding relationships in data, also quite important. Something that most people think when you say data science is machine learning and AI. It's not all that is about data science. It's a big part of it, but it's not the most important. It's something that you learn how to do. All we want to do machine learning and AI and all of that. A lot of companies, they want to create we call that a data product, something that enhances the data experience of a customer. Be, for example, when you use Netflix and it just recommends the next movie to you, that's actually a data product from the data science team at Netflix, where you have recommendation engines and things like that. It can be something, for example, Robobank, they have a data science team, they work in order to optimize the routes for the different drivers. And when you order a driver, which driver is going to get assigned to you? That's also a data product. You don't see that, but it's actually data science happening behind it. And of course, similar to what we do here, is tell a relevant story out of your data. Use the storytelling aspect of that. There's a lot of different things that you can get from data science, but I've had people coming to me, okay, I have all this data, do something for me, I want to increase my revenue. That's many, data science is not a magic wand. It's not something just because you have the data, you can say, oh yes, now you can do something. So you need to do a lot of stuff with your data before you can actually do something. So let's take a little bit of how we work as a data scientist. The first thing is we want to ask proper questions. We need to ask, what do we need? And what do we require in order to solve a problem? What is actually the problem? What are the parameters that we have in order to solve the problem? Once we work in that project, how do we evaluate our success? How do we know that whatever project that we do with our AI or whatever makes sense? That is actually something substantial. What do we know right now? It is sometimes like when you sit down with a client to talk about data science and you ask them, okay, describe the state of your company, describe the state of your field, and what do you know about that? A lot of people are, oh, I don't know. We have all this data, but I've never looked at it. So the idea of a data scientist as well is you look at what is there and you try to find out what do we know now? Because sometimes what we know now is actually enough. Sometimes you don't need to go deeper. You say, okay, if you actually formalize what you know, you all of a sudden have your answer because it's already there. Sometimes it's as easy as that. But you need to know where you're standing. If you don't ask this question, okay, what do we know now? What do we know now? You're actually going into a room with a light and you're trying, okay, I'm trying to find something, but you're not actually. Look, you need to know what the current knowledge base is. You can look at your data and describe it. Descriptive analytics, data analytics is something is a step in data science. I have some colleagues say, oh, data analytics is boring, that's something completely different, that's not data science. It's actually not, it's actually a big important part of data science is successful data analytics. And then of course predictions, that's the nice part of data science. You want to have data and you want to create predictions based on your data. And this is most likely the most useful part of it. Is what we actually understand with a lot of these algorithms. We want to predict how the market is going. We want to predict weather. We want to predict the traffic pattern. So it's a lot of different things. We want with the data that we have, we want to know what is going to happen so that we're prepared. That's one of the most powerful applications of data science. And again, is okay. What do we need to do now? Okay, I know what I have, I know what I want, I know what I need. So how do I get there? So that's the final question, what actually will define the project. And as I mentioned, okay, now you know these questions, you can design the hypothesis, do data experiments, and you can start working on that. So the data science project is actually not a straight line. It's a very complicated process where you actually go iteratively between these steps. You always go back and forth. You identify your problem. You want to know, okay, what are my objectives? What do I want to learn? Very difficult to do this. And you want to, as a data scientist, be if you're working as a consultant or if you're learning in college, you talk to in your classroom, with your classmates, or if you're in a big organization, you talk to your boss. It's quite important to ask the right questions. Asking the right questions to understand what the problem is what actually makes or breaks a project. There are so many data scientists out there that say, oh, yes, because someone comes, oh, I have the data, do that, and, oh, yes, I will. And then like totally fail because they didn't understand what actually the question was. You need to really make sure, okay, what does your boss, what do your client, what does your teacher want from you? Or what do you want if you are working for yourself? Now, what is actually the question? Ask the question before you start working on it. You need to know your question. Without that foundation, your data science project is not going to work. These 4 steps may take 80 to 90% of your data science life, which is basically acquiring your data, parsing your data, mining your data, and refining your data. Now, acquiring your data, as I mentioned, it may be, if you're lucky, you're working in a big company, you have a lot of data, you have your data. So that step may be already very done. But if you go back to the question, you identify the problem, you say, okay, we have a lot of data, but we don't have the right data, because we may have all of these about our customers, but we actually, in order to do something business-wise, we need this extra information, so we have to go back and collect the data. So it's quite important to identify the data you need and then apply it. Parsing your data is quite important, especially when you are using data that is not your data. When you're buying data from different sources or acquiring data from different databases, you need to be able to read that data and understand that data. It can be sometimes, it seems trivial, but it can be sometimes very annoying. Again, from personal experience, from many different projects, the thing that I hate the most is working with dates. Because you get data format in Europe and you get a date format in European format, and you get a data set from the US and it has the date in the US. And if they didn't pay attention, and you just actually imported them, and then everything is then a mess. So like just that, a tiny thing, because once someone uses year, month, day, another one uses month, day, year or something, it can be very, very annoying. Something like that, or even the units, like someone is using kilometers, the other one is using miles. And if you don't really pay attention to that, you actually get data that doesn't fit together. So just understanding your data. So that's passing data. Mining your data is also something that, okay, now we have big data, and that means sometimes we can work with millions and billions of data points at once. But even then, sometimes when you create your data, your data project, you don't want to use all the data at once. So you need to know, okay, how do we want to actually sample data? Sometimes you want to understand patterns in your data without having to look at all your data. So how do you create a data sampling methodology? How do you know that the sample that you're collecting is representative? Same like when you say, oh, the US, you want to do elections and you want to understand how it says. You don't go and ask every single person in the US how they want to vote. It doesn't work like that, especially when you're just going before the elections. You take samples and you ask people, basically, and you decide, okay, how many people do I need to question? Which people do I question? Is this sample of persons representative, or is just to buy that? Things like that. that it also concerns environmental data. You cannot measure every single parameter everywhere in the world at the same time, every day, every second, right? You need to be able to say, okay, what data is sufficient in order to identify these patterns? So like all of that is a game of tuning parameters until you get the right formula. But you actually rarely, because you have like these supercomputers and everything, you cannot use all the data that is available. That's just basically not possible. The more data you have, it can become more useful. But there is a limit to your returns. At some point, even when you get more data, the gains that you get from using more data is not you don't get much more information. And at some point, you're actually losing because you start getting just overwhelmed with so much data. And now everything.
Battery's gonna run out.
Huh?
The battery's gonna run out.
Oh, it's not. It's not.
It's not connected. I'm sorry, everybody.
Oh, it's not like that.
Yeah, I mean, I think
This is blocked.
maybe your computer rules it.
Oh, it's okay.
Next one.
Okay. And only again when you have actually made sure your data is there, the data is clean, that your data is relevant, then you go into this nice phase of data science, which is creating model. When you go into your machine learning, when you do it to your data. If you go to a place like Kaggle, I don't know, have you heard of Kaggle? Kaggle is an online, it's a website. They have competitions for data science. And basically what you do is you actually ignore all of this and you go directly to this point. They give you the data, they give you the question, they tell you what they want, they tell you how you're going to measure your success, and then you okay, go. And then your job is, okay, you take all the data and you start programming and you build a machine learning algorithm or something, and then you give them the results, and if it's good enough, you build in something. Okay? So Kaggle, for example, is a very good tool to learn how to apply that technical aspect of data science, of machine learning and AI programming and all of that. But it forgoes a very important part, because to be honest, at least for me, it's the most boring part of data science. It's the difficult work, it's the one that a lot of people don't like. It's actually quite hard work, and it can be quite hard. But it's actually, like when I did my PhD, I spent 4 years doing this, and I spent 3 months doing this. So that was my PhD. 4 years of that, 3 months of this. Yeah. Okay. So and that's the reality of it. That unless you're very, very lucky or you're playing around the Kaggle, you have to spend a lot of time with that. Okay. And the idea is very often you build your model and you see, oh, it's not enough, I need extra data. So you have to go back and get more data. And you say, oh, I extracted the wrong data. So whatever I need was valid. So you have to go here and then take a different example. Or you say, oh, I will get it in the wrong place. You have to go here and change the data, do it a little bit different. So you are going to be moving back and forth with your data until you actually get the results that you want. Okay? So that can be, the path of data science is not straightforward. And what you see most of the time when you go to a lot of these online classes and everything, they are concentrating on this part. So how when you have the data, how will you do the programming, how will you make the nice machine learning algorithms, deep learning, you do all these very nice things. It's actually only this part. There are very few courses that actually concentrate on this, because it's also difficult to teach in a way. So it's something like that. And last but not least, then is you want to present the findings. Doing an infographic, doing a video, or you create something, an interactive tool that you give to all the data scientists. So how do you present the results of your project? There is a tool called Jupyter Notebooks. It's like right now, if you look at anyone who's doing data science online or whatever, everyone is talking about Jupyter. Yeah, what's that? It's just basically a web-based Python environment where you can do a lot of data science projects very nicely. And once you have made it, you can actually give it to someone else who also have Python on the computer, and they can run it and say, oh, cool, it works with this one. So it's a very nice tool and may demonstrate the data. But just keep that in mind. If you go online or to many classes to learn about data science, you're actually learning about this tiny part. Okay? Let's move to the presentation, visualization.
So yeah, the final part, which is the presentation, can also be broken down into its own set of steps. So visualization. So yeah, the visualization process seems like a small part of the process, but it's very important because, like you said, when you're working with PCC, you can do all the work beforehand. If you can't communicate it correctly, it's not going to have the impact it should have. So the visualization process starts with defining what your goal is. You need to know why you're doing it in the first place. Then the audience is very important because depending on who you're talking to, the arguments and things that make them care, make them tick, are going to be different. Then comes the story. It's got to have a beginning, a middle, and an end, like any story. And that's how you walk people through the message, through to the message, which is the punchline of your story. Because the story is just the background. You may have heard it somewhere before, but what's going to be unique about this visualization that other ones haven't done before? That's the message. Now, finally, you want to put this all together into an actual visualization. That's kind of like a fun part because there's some design that goes into it. You need to make sure that the message is very clear, that there's a visual hook, that somehow it's appealing. But you also want to be scientific about it because you're not just using colors for decoration. You're using colors for a purpose here. So it's kind of like a mix between science and art, which I find is very fun. So here's a particular case study of a project that we're putting together right now, which is about permafrost thaw. Now, our goal is to raise awareness about this phenomenon. And right here, you're looking at the Batagayka crater, which is somewhere in the boreal forest in Siberia, in Russia. And as you can see, the image itself is quite powerful, and it can maybe elicit a response in some people. But the problem with just an image is that you don't get any context. You don't get the beginning of the story or the end of the story. You only just get this one part. So sometimes a picture isn't enough. That's why data visualization comes in. But that's just the beginning. So once you have your goal, I want to tell you about permafrost thaw. That's great, but who am I telling permafrost thaw about to? Am I going to be talking to the general public, or am I going to be talking to policymakers? Because the form is going to be very different in both of these cases. So if we're trying to raise awareness in the general public, you need to think about what makes them care. And here are a few examples. If you're talking about individuals, well, things that affect their everyday life, that might make them care. So prices of goods and services. If climate change is going to start affecting the prices of things you buy on an everyday basis, you're going to notice. The availability of essential and non-essential goods, for example, like if you have no more water, trust me, you're going to notice. And the quality of life, like temperature, but also natural disasters, climate, weather, extreme weather events, which can have material damage. They can affect sanitation, water sources, like flooding is a big problem in some parts of the world. So yeah, if you can show that these things could actually happen to you, people are going to listen and they're going to react, because there's a difference between caring and also actually wanting to react and do something about things. Ideally, you elicit a reaction. The next thing is the state of our planet. Now, some people do care enough about the state of our planet to react when they hear about species going extinct or about habitats or ecosystems being destroyed. But one really powerful thing I think is, as we said in the video, the intro to Earth.org, is looking at the past and the present to kind of extrapolate towards the future. Because if you can tell people today about what the consequences of their actions and lifestyles will be in 50 years and how it will affect, within their lifetime or the next generations, because some people do think that far ahead too, it could be a very powerful thing to do. Obviously, the climate's a very complicated system, so making predictions is always going to have some assumptions. But this point is to kind of convey the message that we're taking a risk rather than this is what's going to happen. So, in this particular case with permafrost thaw, the story isn't so much a beginning, a middle, and an end, but rather a cause, effect, and impact. The cause of permafrost thaw is temperature rise. The effect, as you saw, is that kind of crater. Permafrost thaw can lead to, well, actually, we'll go over the mechanism in a second, but let's move on with the impact is methane release. Now, methane release is a greenhouse gas, and greenhouse gases actually increase temperature. So you get a feedback loop where you come back to the initial cause. And these positive feedback loops in nature are something that are very important to understand correctly because we don't know when they can get out of control. So this is how it works. As you can see, temperature has been rising in the northern parts of the globe about 3 times as fast as in other parts. And because of this, these forested plateaus that are propped up on permafrost, which is kind of like frozen ground, holding the floor up, is going to thaw. And these are going to kind of tumble and crash, and the permafrost is going to become wetter. So you get, instead of cold, static forests where biomass has been just sitting for millions of years and just storing up carbon, you get these hot, wet marshes instead that are increasing in area. These marshes have a lot of biomass degradation through microbial activity, and because it's wet, rather than releasing the normal carbon dioxide, it's going to release methane, which is about 24 times stronger in terms of radiative forcing than carbon dioxide. So it's a very, very important process that is unfortunately very poorly understood. What we're trying to do is we're trying to piece together the information that's out there to show you what the consequences could be and where we could be going. So that's the story. Once you've set the story in stone, you want to bring something extra, because you guys may have heard about permafrost thaw and methane release in the northern parts of the world before, but what's the real punchline of our message going to be? Well, for this, you need to sift through the research and you need to create that future vision that Earth.org is trying to bring to you. And to do this, you take what we currently know and you try to extrapolate and you create models for the future. But the most important part of this is to always make your assumptions clear, because even the best models by the IPCC are going to have some flaws, and they know this. But the point is to, once again, be as prepared as you can be for what comes next. So the punchline of this particular story is to make people understand how much of a risk these wetlands represent and the methane coming from these wetlands could represent. Because if you look at this axis here, what we have is the amount of CO2 released from today onwards. We're here at zero today, which is actually 950 gigatons emitted since the Industrial Revolution. This has resulted in about 0.8 degrees of temperature rise globally. This is like a mean temperature rise. Now, if we release 975 gigatons from now on, so basically what we've emitted since the Industrial Revolution, by 2100, which is a very, very good scenario. That means we've taken major action. Then we'll get between 1 and 2 degrees temperature rise, more or less. There's always a degree of uncertainty because there's a lot we don't understand. Then, if we go much further, but not too far, 1550, we'll not go too much further, we're going to be at about 2 degrees Celsius rise. But 2720 is where we would be in 2100 if we kept releasing carbon dioxide at today's rates. Now you can see that the additional warming from boreal methane is nothing to be ignored, because it will take us from 4 to nearly 5 degrees increase, and that's only by 2100. If this happens, what we've actually done is we've locked in a much worse fate, where that positive feedback is going to come into play, and a lot of the methane and carbon stores in the northern parts of the world will be released. So the point of this message is to raise awareness about this phenomenon, because there's a lack of research and a lack of understanding, and the truth is there's a lack of funding in that area too. So by better understanding the mechanism, we'll be able to better prepare and maybe even mitigate its consequences. So that's why we do this. There.
Okay, let's put all of that together. And I need you guys to be a little bit more active. I'm so quiet. Let me be more active. We need a little bit of work now. You guys, like, imagine right now you're a junior data scientist or you're an intern or doing something, and you're working at Amazon or any other online retail company. And your boss comes to you and says, okay, by this afternoon, I want you to put something together that tells me if a client who's right now online on our homepage will make a purchase or not. That's a very common scenario you may get with any company, like say Amazon, you both come, okay, I want you to tell me how would you predict if a customer will buy something. Okay, that's your job. You don't have to do all the programming or everything, but you have to actually put a plan together. So let's put that data science plan together. Okay, so remember the step number one is we need to acquire data. We need to parse the data, so basically read the data. We need to mine and refine that data, basically extract the information that we need and put that together in a way that makes sense for us. Then make a prediction or something, create a data model, and then present our results to our boss, to colleagues, and maybe go on to the CEO. It depends who you have to present. Okay? So let's put that together. Acquiring data. You're working at Amazon and you need to acquire data. Okay, what data do you acquire? How do you do it? Yes. Okay. Okay. How do you get the data? Just before you go into, let's see, you're working at Amazon and someone is online. What data do you have about? Do you have any data about that customer?
If you have an account or not.
Information.
Yeah, because remember, one of the first questions that we ask ourselves is, what do we know already? So when if your customer is logged in and is in your homepage, you know his name, right? You know his address. You know his history because he has bought other stuff before. You may know not just the history, but the patterns, because you may do that later, but you know when he bought what, right? What else do you know? So let's think about that. What do you know already?
How long does he stay in the website?
Okay, how long he's been online and how long he normally stays online. What else?
Yeah, he usually lives.
Yeah, where he lives. Yeah, that's also quite important. What else?
Payment method.
Payment method. Yeah. So we have, when you look at that, and that's actually quite important. You take a look, okay, what do we know already? And you actually know already a lot about a person who is your customer if you're a company like Amazon, okay? And based on that, you may decide, okay, I may want to get extra data. Then you say, okay, yes, but we need more data. So what more data would you want, would you like to get? What else would you like to know?
What kind of products the customer's friends and relatives are looking for?
Okay, if you can make a connection to friends and relatives, what they also bought, okay. What else?
Or someone who is like the customer. So someone with a similar profile.
Okay, you want to aggregate his data and start looking at collective data. What else?
What is the day of the month?
The date. Okay.
I'm going to buy something, there's an option to buy something for Christmas, kind of that.
Okay, good.
The day before the Black Friday.
Okay. And that basically, when you're creating with your data, it's just that now you're collecting a lot of extra data. You may have, for example, other information like, oh, this person came to us referred by another link. Did he click, for example, on an ad on Facebook? Or did he click on a link from email that we sent to him? Or did he click on the same homepage on Facebook or on Amazon and say, oh, customers who bought this also bought this, and that person clicked on that. So how this customer came to your page is also quite important. Right? There's a lot of information that you know, and other information that you can get. And you may say, okay, from now on, we want to get an algorithm that tracks certain behaviors about the customer, things like that. So you can actually start looking, oh, what else would we like to know? And then you start actually expanding the profile, the data profile of your customers. So actually, it's how you start thinking, okay, yeah, that's all the data I collect, and it's just one person. And you start looking, oh, we need more person, we need more people. We need data over a period of time. Like, you don't want to do it only today, because seasonality is quite important. People buying stuff for Christmas. Or if we connect time and location, because someone shopping in the US around Thanksgiving will probably buy stuff that is Thanksgiving appropriate. Or someone in Hong Kong at the same time said, I don't care about Thanksgiving because I don't celebrate that, right? So knowing about the geolocation and about the time and how it relates to that person, and maybe you have or information about that person, the ethnicity, the cultural background, religion, because all of those may play a role on what this person buys, when and where, okay? It's also that. You may know, oh, is this person married? Maybe this person wants to buy stuff for his wife. Does this person have children? Because he may want to buy toys or things for himself, not for himself, but for kids, right? So knowing a little bit about the family of this person may be also important to decide, oh, this person may be interested in this, or he maybe buy this or not. So there's a lot of data, and when you start getting that, and you start putting that together. Oh, this person lives in Hong Kong, and right now is Chinese New Year, and this person most likely will buy, I don't know, red envelopes in Amazon, or someone will actually do that. Yeah, so that will tell you, yes, let's advertise there, let's spam this person with advertising for red pockets, right? So you start looking at your data and see, okay, what information we can extract? Then how can we create data aggregates? Like he mentioned before, okay, you compare a customer with other people, and that's what you have this in Amazon. You say, oh, people who bought this item also bought this. That's basically using that. It's looking at people who have a similar profile to you or a similar history and says, okay, we actually think you may like this because other people like you did the same, okay? And then you start putting your data model together. When you start saying, okay, if this person is shopping has been on our homepage for 20 minutes, and it's this time of the year, and this person is located there, and because he bought this before, he most likely will buy this. So let's initiate like a chatbot or something to get this person to buy. You can have some of these homepages are annoying when you click away. They come with a pop-up, wait a minute, don't go yet. And you get a free like 10% discount or something like that. Because they know, okay, you offer them something and they will know, maybe I stay and I buy something. So those are things, behaviors and patterns that you learn from your data. It doesn't have to be big data, no? Because it is based on your customers. And if you're not a huge company, your database may be relatively small, but it may be already enough to get some data, some patterns that emerge out of it. Okay, so now that we have thought about, okay, we have this data, we can acquire this extra data. Now we can aggregate and combine in this way. Now we create a model, and we can actually say, okay, now we have a potential algorithm that can tell us if this person is going to be if he's going to pay something, buy something or not. Now we need to present our results, right? And how you present your results depends, as he said, on your audience. So if you're presenting your results to your boss, like if you're your junior data scientist and you're presenting that to the senior data scientist, how would you present that? How would you present your findings?
Maybe using the more statistical terms, like mathematical terms.
Yeah, you will probably be quite technical, right?
Technical.
And that's what I was saying. Okay, when I was in the panel of climate change, we were presenting all this information very technically, like for all our scientists. But if you're talking to people in the same area, then being technical is okay. But what if he says, oh, very nice, come with me, that you want to do a 3-minute elevator pitch, or you're going to go to the sales team, to the marketing team. How would you present that to the marketing team? Will you be technical? Will you start talking about programs and Python and functions and so on? Then the marketing team will be why? They don't understand. Right? So you need to be able to actually change your message and present it in a different way. So how would you present this same information to the marketing team? Using graphics, yeah. Maybe, okay, projections, take a look at Venn diagrams or something like that. Do something nice. And then the marketing team is very impressed with you. Say, okay, let's go and we will do a mini presentation to the CEO or something like that, regional manager. Would you do the same presentation or would you change something?
Yeah, more in terms of like sales, like maybe revenue, increase revenue.
Yeah, probably you will talk to the marketing team and say, okay, can you give me some marketing data? And then just basically go back a little bit and put that together in your presentation, expand it. So every time that you get a different audience, you need to think, okay, what part of my data product, which part of my finding, which part of my process will I present to the customer? Not because a lot of people are not really interested in what the technical process behind it. Oh, I don't understand any of it. Yeah, you're using some machine learning, cool. But I don't want to know if it is decision trees or if it is deep learning or something weird. Right? They don't understand it, they don't care. They say, oh, you're doing that. So you would do something like present, like if you present to some people, if you go to accounting and you present with them like some financial scenarios, and you say, okay, these are assumptions, and we do this and we do this revenue. They may be very happy with that if you present just some formulas and just some tables with data. Maybe the CEO wants to see that as well. If you go to different people, they will want to see something different. But at the end of the day, you're actually communicating the same message because you have a message. And that's what we were talking about before. You have actually distilled your message, and at the very end, you decide whom you're delivering this message to and how you want to deliver that. And as a data scientist, this part is quite important. So I innovated that. So to summarize what we did, we want to collect data around user retention. So is this guy going to buy something or not? User actions, to look at the history, is this person likes to buy stuff or so? And maybe find data from outside the company, for example, look at referrals from other maybe this person came from there. And if you can actually link profiles and say, okay, the person is from Facebook, he posted something awesome about this product, right? I don't know. It's like the aggregated data, which one we saw about, oh, people like this person, like everyone who shared this profile bought a similar product, things like that. Or people during this period of time tend to buy this type of products, right? And people around Christmas buy things at Christmas Eve, right? If you have connections to other pages, like, oh, this person shares, things like that. Is this person reacting to your emails? Is this person reacting to your marketing or not? Find distributions and correlations, as we just mentioned, with seasonality and other areas. And then you say, okay, based on this, we can do a prediction, and then you share the results. For example, as I mentioned, using an interactive presentation is Python, this Jupyter Notebook, which is something interactive, where you can run something in front of a person. And then, again, after doing all of that, you're talking to your supervisor. And your supervisor, oh, nice and good, but you make a mistake there. You don't have enough data here. Or that data is actually illegal to collect. And you say, oops, sorry, my bad, you have to go back and start doing it again, right? Again, remember, data science doesn't exist in the void. You may say, oh, yes, we collect all this data. I have this awesome model. And someone tells you, okay, sorry, we have the Data Privacy Act. It means we cannot store and use this data for this. And you say, oh, okay. So I need to create a new model that ignores that data because it's actually illegal to use the data. Okay? So you need to be aware of things like that. We don't exist in a void. Keep that up there. Okay? So now we just sorry, I changed the order just last minute. So now let's get a little bit technical. We go through all the theory, let's go a little bit more technical and then do the demo. Now, one of the skills that we need for data science is programming. Again, you don't have to be an expert, but having some basic knowledge is important. And if you go into the data science field right now and you Google it, you will find that maybe 99% of people will tell you to use Python. Personally, I also love Python. Although I started using C++ and then I did COBOL and R and other different programs, I personally also love Python just because it's super lightweight, it's super easy. I have Python on my phone, so sometimes I'm bored, I can take my phone and do some really bit of data science on my phone. It works, which I find it awesome because it's like, oh, Python, it works. So Python is actually very lightweight, and it is not just for data science. If you learn to do Python, you can do a lot of other stuff, all other data science, not just data science. If you do a language like R, R is very similar to Python, but it's specifically done for statistics. So it's nothing that you would use R to create a game or do something else. It would be basically just for statistics. And Although Python and R are very similar, personally I like Python more because Python was created by and for computer scientists. So basically it's a very robust programming language. R is very similar, but it was actually created by mathematicians for mathematicians. So when you look at it from a computer science guy point of view, it's horrible. It's like, oh, so many things are like sometimes contradict each other. It's kind of like incomplete, and it's like, some things are really amazing, but other things are, for me, very broken. But that's just my personal taste. Maybe you look at R and you say, oh, R is amazing, I want to do R. It's up to you, right? I personally use Python because it's just lightweight, elegant, very easy to use, very easy to learn. And it has a lot of stuff already built in that is very helpful for data science. So in Python, out of the box, can do a lot of stuff, but it's not all powerful. And that's very nice because you can get Python and install it, for example, in a Raspberry Pi, in a tiny computer, and run really nice things just in a tiny computer because it's very lightweight. If you want to do something else, you need to install extra power into Python, and you do that by installing packages. So package is just basically a little bit of extra functions and technical mambo jumbo that you can put it into Python to do extra stuff. For example, one of the things that we use a lot in data science is called pandas. Pandas is basically Excel on steroids. It's the same as Excel, but you don't have all the point and click and all the graphic interface, but you have everything behind it, way more powerful and faster than Excel. Okay? So it's basically how do you deal with data in table form. It's actually quite powerful, but you need to know how to program a little bit in order to use it properly. You can do a lot of math and a lot of weird stuff using SciPy, Scientific Python. Now I'm dyslexic, so every time I see the word, I always read as spicy. I remember one of my very first lessons in Python. Okay, you can just do import spicy, and error. Why error? And I look at my program for like 5 minutes until I actually realized I wrote spicy instead of SciPy. So that's one of my. So with SciPy, you can do a lot of very weird stuff. You can add a lot of functionality. If you want to work with matrices, imaginary numbers and weird stuff, you can use NumPy. If you have a lot of functionality for that, you can add. There's a lot of machine learning packages now out there. They're quite complete. One of the very first things that came out is scikit-learn. It's actually one of the first. It's quite old. But if you do any Python class for data science, most likely you will start with scikit-learn because it's so basic. But nowadays you can do a lot of very nice, really stuff. It's just install it, just run a line of code, and it's there, and you can run it and use it. Then there are a lot of different data visualization tools like Plotly that you can create really amazing interactive graphs online and everything. It's very powerful. One of the that is Seaborn and Matplotlib is also one of the very basic and one of the classics in data visualization. And again, if you do a data science class, for example, in Coursera, although you have all these really amazing data visualization tools, almost everything goes back to this Matplotlib just because it's like a pillar of data science. Everyone should know or have used it a little bit before because you need to understand how a graph is made out of your data, and Matplotlib is kind of like down to earth. You need to know what you're doing. So you create nice graphs, and then it teaches you how to think around your data to make a nice graph. Once you know how to use it, you can use more fancy and more powerful libraries, but you need to understand what is happening with your data when you visualize it. And there are a lot of other different tools nowadays because there's so much data now online. There's so much stuff you can get out of the web, and sometimes it's just hidden in home pages. Like I know someone who was creating, he wanted to create a program machine just for fun, a data science project, trying to predict the winners from the hot spaces in Hong Kong. And for that, he needed the data of all the jockeys and of all the horses in Hong Kong from Jockey Club. Now, you can go to the Jockey Club page and you can actually collect all the data of every jockey and every horse is there. But they don't have any way, any tool that you can download it. So what he used, a tool called Beautiful Soup, that basically is like an automated browser. It just basically goes to each jockey and each horse in the Jockey Club page and downloads the data from there. So just reads the homepage, extracts the data, puts it in the database. So you can actually extract a lot of data online using tools from Python, for example. Not every company, not every firm wants to give you, they have the data, but not everyone wants to give you data. And one of the problems in Hong Kong, for example, in Hong Kong there is a lot of data, but it's very difficult to get open data in Hong Kong. Like the government offers a little bit of data, but it's not enough. But if you go to government pages, you can actually get a lot of information just in the home pages. But you need to use workflows, and you need to actually go and collect the data with a body, basically. You cannot just download it. So, and there is a wealth of information out there, and it goes back to one of the steps that I mentioned before, collect your data. Sometimes it's just, okay, you go back, you look at home pages, you understand the structure, you create a bot that reads the home page, and you know where the information is, and then you collect it, and you just go around and collect the data. I did a project using our universities in the US, and I just basically created a bot that got all the information from Wikipedia. So, things like that, or like if you want to collect all that, it can be done. It takes a little bit of work, but it can be done. Okay, so let's see if you guys want. Let's run a minute more. No. Okay. This is the, oh, this is horrible, difficult to read. Okay. So this is this famous Jupyter notebook. Do we have time? Okay. This is basically the Jupyter notebook that I mentioned, that right now is on my web browser, and it's running Python in the background. So I don't have to open any special program or anything to run Python. It's actually just on my browser. And it's very nice because you can create, this is just HTML basically. You can have text, you can create things, you can save that as a PDF and give it to someone. So it's a very nice way to just create a little bit of a data science mini project, or not just actually data science, something that has code, and you can use it to create a presentation or pass it to someone. I think let's just this one. So this, okay, print hello. What do you think of this? Is this about? We just print what hello. If I run it, you can run this line of code. It just basically tells you what it is. You just basically wrote. That's a Python program. That's as simple as that. In other programming languages like Java or C++, you have to write, I don't know, 5 to 10 lines of code just to do the same thing. That's why I like Python. It's really, really easy to run. You can interact with your, we should try and get listing all the data in the directory, for example. I can add this NumPy and pandas, for example. When I run that, it's now in memory. That's as easy as that is. Right now, these tools, pandas and NumPy, are in memory in my web browser. So, and this is just something else. Okay, now, Let's do a little bit of fake data. Imagine in Excel, we want to create a data sheet that has information about different cities in the US, where they are located, the income and population of those cities, and then you want to do a little bit of analysis about this data, right? Like now, I create with this line, I'm just basically putting in memory one column of data, right? And if I print it, it tells me, okay, now I have a list of cities in memory. Pay attention, we're starting counting at 0. That's very weird. In computer science, in a lot of programming languages, we start counting at 0. And that sometimes for beginners, you do something with your data, whatever, and you think, oh, the first item is number 1, and then everything looks very wonky. It's just because very often we start counting at 0. It's something like we was decided a long time ago, and it's okay, we add the cities, and now I want to add the states and income and populations. Now we have actually just created 4 columns of data, and those are just 4 columns just floating in space. They are not linked together. In Pandas, in order to create what is a sheet in Excel, we call it a data frame. And basically, I'm telling you, okay, create 4 columns and add that data in those 4 columns. And I do that. And now the data is in my. Let me see. If I print it, I have now this whole table. Now, this table is not just only 10 elements long, it could be 100,000 elements long, and it could have more than 4 columns. And if I ask you in Excel, okay, can you give me a statistical description of your data? You would have to define, okay, create the averages and then just copy along all the things. It can be done, but it can be quite challenging, not fun, right? So it can be very annoying to try to do it in Excel, especially if you have long columns and you have to select everything, and then if you want to copy across or something, it can be sometimes quite slow. Here, I just tell Python just one line of code. Oh, describe the data for me. And it tells me, okay, we have 10 items. For the income, the mean is 49,800 for city population. Now, when you look at this data, do you see this is human readable data? Like, who of you in daily life writes 6.00000 times 10 to the power of 6? That's something that we are not used to. It's correct, but it's not a way how we actually look at data and numbers. Same with the income. We don't write 56,750.000. We normally say, oh, 56,000 or something like that, right? So this is raw data, but it's not the way how we normally as humans deal with data. If we want to create a graph, we want to clean up this data a little bit, okay? So what we do is I want to set population in millions of people and income in thousands. So I just basically create a formatting function that makes it, okay, give me the population in millions and create a new column called population in millions using that function. And I do the same with the thousands. And if I look at my table now I have population in millions, 5 million. It's so much easier to read than that. And income in thousands, 55,000. It's so much easier to write. Now this is no longer raw data, it's processed data. Basically, one of these data we had, which after passing, we want to aggregate the data, modify the data. This is nice data that we can use for graphs or to present the data to other people because it's now in a more human readable format. Okay? Okay, you could go in Excel and just format your numbers so that they look nicely, but you're formatting the numbers, you're not changing the meaning of the numbers. Right? Here, you're basically creating extra so that we have a different dimension. Oops. This is just like we want to know we have 10 columns, 10 rows and 6 columns. Like knowing the shape of your data is quite important because you can find out if you have missing data since I guess already at this level you could find if you have missing data. And you can filter, for example. An easy question is if I ask you, okay, I want to know just the first four, the income and population of the first four cities in the table, I can actually just call it out and say, okay, that's the data layer. You can actually extract windows of data very easily with just a line of code. And if you have a program, you can actually move around your data and just collect whatever you want in a very, very simple way. If you want to do something like in Excel, you have to do pivot tables, you have to create filters, it gets complicated quite quickly. So it's easy to do, or relatively easy to do, but it can get complicated quite quickly. With this, you can, if you run the programming, you can do a lot of stuff very quickly, very easily. For example, I want to see all these cities where the income is below 30,000. And I just basically say, okay, give me all the cities where that value is less than that. Instead of having to go to the column and click on that and create a custom filter or something, I can do it very easily and extract the information out of it. Of course, I can sort. I can, for example, I want to sort by population. If I say ascending, now the population is ascending. Ascending one in computer science very often means yes or true. If I say 0 means no or false, ascending 0 means basically descending. So if I do it this way, then you see that the population is now from large to small. So I can easily and as before, I start getting into my describe, and this becomes so much easier because I know now I have 10 items. The mean population is 2.4 million, the mean income is 49.8 thousand. It's so much easier to later to understand than these numbers. It's still the same information, but it's easier to digest, right? Like a pivot table in Excel, I can group this data by states and, for example, create a mean for each state. And it tells me, okay, the mean income per state in Florida will have 50,000, in Georgia 44,000, New York 56. So I can create that very easily. Also, this population will be the same. Right? Or I can even describe, and I can get statistics from Florida, then I get city income. From Florida, only 2 cities in Florida in our database with this mean, this standard deviation, this mean max. So I get a lot of statistics, everything. Right? So it is visually not the greatest. It's not meant for visual appeal, but it's in terms of computation very easy, quite easy to use. Okay. It has its limitations of your data. If you have a lot of data, then other tools will be more useful. But it's quite powerful. Now, looking back at what he presented in terms of visualizing the data, why do you think that visualizing data is important?
The message might be understand easier.
It may be easier to understand the message. I think there is a more important reason, and I think it was mentioned at the very beginning, and is if we take a look at a table of numbers like this table is relatively small, but this table is relatively small. But can you see any patterns in this table? We have only 10 rows and 4 columns, but can you see any patterns there? We have only 40 values there, and looking and trying to find a pattern in these 40 values can be impossible just with human eye. We are not actually made to look at these numbers and try, oh, yes, take a look at in New York City, this and that. We can't. So we are not actually made for that. And one of the most important uses of data visualization is if you use the right tools, is that you can actually visualize patterns very easily. That is something that we can see. Our brain is actually made to recognize patterns. And it's actually sometimes dangerous because sometimes we see patterns when they are not. You have to also be very careful with data visualization. You can't lie with your graph because the human brain is actually wired to see pattern. That's why sometimes you look at clouds and you see, oh, I see something in the clouds. Or you look at something, oh, that looks like a face. Because our brain is actually looking for that. And visualizing data can help you see a pattern. But then that's the beginning of your data science. You say, oh, I think there is a pattern. And then you can design your data experiment to try to verify that pattern using data science. So it is, don't say, oh, I look, this is the graph, and I see this pattern, and this is true. That's misstep there. So if you see a pattern, that gives you a beginning, and you say, okay, let's start from that, because I see something, let's verify that using a data science experiment. And now we can go with a more guided approach. So visualizing your data will allow you to say, okay, I think I've seen something, I can start creating my hypothesis based on whatever I've seen in this visually, and I can try to see, okay, I want to see if there is a pattern or something. Okay, right now this doesn't say much, but you can, from different visualizations, you can see, okay, if you have bars, if you have scatter plots, you may see, oh, there may be a correlation or not. So visualizing your data at the very beginning can actually send you in the right direction. So it's this analyzing your data, visualizing your data, just understanding your data is actually so important for data science. And only once you have done all of this, you can sit down and say, okay, now I want to program and do machine learning and do all of that. So this is what you actually need to have understood before you do data science. Okay, any questions? No questions. Okay. So data science is not new. If you study data science, one of the things that you will find is this famous IRIS database that you can do a lot to create, just classify different flowers based on the measurements. That data set is actually from 1936. So we have been dealing with data since ancient times. The Egyptians were doing data science. It's just we didn't call it data science, okay? So data science has been part of our life since we actually collected data, right? So it's just nowadays we have really powerful tools to do that. Questions? Any questions about this?
Once you get to those graphs, how do you export them to like a PDF? Because you eventually, I want to generate. Can you just generate from the Jupyter notebook or PDF?
The small graph?
Yeah.
Oh, now what's that's there. Okay. Just here, I want to create a table using, I want to plot the incoming thousand. And just basically, I want, in this case, I want to do a bar graph. And they just basically a percentage. It's just a very basic, boring graph. I mean, they are way nicer graph that you could do with data.
The thing was referring to like have a image like
Because let's say I want to send to my manager and he won't be seeing this, he wants to have a PDF file.
like a code to like import as export the graph as
Oh yeah, I mean, you can take that and you can save that and you can export that as
but just a graph.
just that one.
Yeah.
Oh, they are.
There is a code. Just
Okay.
This graph is actually creates the image and it's the image. It's there. And again, this is, as I mentioned, a very basic package. This is super basic, super boring, but it tells you, okay, you can start adding different things that you can add, oh, I want to add more information on the axis, I want to add a legend. You start adding more to your graph. Just basically with that routine, you can understand what makes a graph. And you can add a lot of other stuff. But it's not the most advanced and fancy one. Okay?
I think it's just a project, if you happen to generate a very fancy graph, then how do you communicate or like present it to your manager or management to
Yeah, I mean, if the example before with the Amazon one, if I was presenting this to my, to the senior data scientist, I would send this to him.
Yep.
With the data. Okay, you can take a look, run it yourself. Do you like this or not? Okay, this would be enough for that. But I would never give this to the CEO because the CEO would want to run all this stuff with all the code inside or something. They would probably just extract some of the tables, some of the values, extract some of the graphs. So basically what you have produced, like this table, is basically what we call a data product, right? You have produced something. And if you run an algorithm in machine learning that gives you some data that you have predicted, that you may use to create a graph for your predictions and things like that. Right? So like what you use in order to do the presentation will actually depend to whom you're presenting, right? So now in the data science community, so the Jupyter notebooks are very well known, and in Kaggle competitions, a lot of stuff is just given as notebooks, and people will say, okay, can you check my data? And they send you a notebook or a link to the notebook online, things like that, because this has become ubiquitous everywhere. It's like, oh yeah, it's very common. That's why using Python and using Jupyter notebooks has become like, oh yeah, no-brainer. Even if you're doing deep learning, if you do the deep learning class in Coursera, for example, with Andrew, is using really big data, with doing really nice neural networks and things like that, or like that's high-level machine learning and data science. They still do everything on Jupyter notebooks. Right? It's everything there. It's quite easy. You just sit at home and then you have to complete the code, you have to code a little bit, you run it, it's everything there. So it's actually quite common. So learning how to use Python and how to use these guys is something to start with. Any other questions?
Do you do analysis in like text information?
But yeah, yes, there is.
Like how do you do it? Because for example, for like Amazon case, like there are some customers reviews, they write some words in, like do you analyze this kind of
So
thing?
there is something called NLP, which is natural language processing. And within that, there is something, an area called sentiment analysis. When you do sentiment analysis, you can take a piece of text and it tells you if that text is positive or negative. If it doesn't, you can say, oh, this person angry, sad, happy. So you can actually try to get the gist of that. So that's actually already quite advanced. If any of you are, what is the name of like, there is this, what's the name? Like, when you're typing one of these apps for correcting your typing.
Grammarly.
Huh?
Grammarly.
Grammarly, yeah. So if you use Grammarly, for example, when you're typing, there is this one icon, oh, this text, the tone of your text is very serious. Or the tone of your text is very happy. Or you sound sad, and it's a small icon. It tells you, because it tells you, okay, how